We
Yeah.
welcome you. So, the participant who is supposed, please take the control.
Yes.
Anupam sir has already joined. Please proceed.
Good evening to all. It is my pleasure to welcome you all to this FDP on exploring AI using IBM Watson and Google Colab. We are honored to have with us an esteemed speaker, Mr. Anupam Sorabh, who is the founder and the solution head at MACHADALO. He has managed the team of 1500 plus professional and was working in the capacity of the executive vice president for a mid-sized company in India. He is a non-conformist bubbling with the restless creative energy. His passions are delicate intricacies of the universe. He started his career as a technology and a process consultant, and his last corporate job involved giving direction to the 20,000 plus students. He also have been actively involved in volunteering, raising funds, running ultra marathon, and the backpacking. With his vast expertise and the experience, we are fortunate to have him with us today to share his insight on the topic Introduction to Google Colab and PyTorch. Please join me in welcoming Mr. Anupam Saurabh. Now session is yours. Thank you, sir.
Thanks a lot, Anjali ma'am. And I'm just sharing my screen. I hope it's visible. Hello.
Yes, sir, it's visible.
So yeah, so basically, thanks for giving an introduction. Okay, so we are all collected over here to understand what Google Colab and PyTorch really are. It's just an introductory lecture, correct? But the idea was rather than just demonstrating, like in terms of talking about Google Colab and PyTorch through a presentation, it will be important if, like I show how simple it is to use Google Colab and PyTorch. So this will motivate a lot of our esteemed professors. And today we all are sitting at an AI revolution. And I believe AICT is doing a fantastic job with Gurukul Kangdi University, where they are bringing this intelligence to the professors. Because when we were graduating, majority of us had very limited knowledge or understanding around artificial intelligence. There were basic neural networks, but it was very difficult to work with them. But today, Nvidia, Google, Tesla, and many other companies have come up with products and systems uh, where it has become very easy to use these tools for a large data sets. And this basic uh, introductory system will help you see the second part. See, professors in generally are very good when it comes to theoretical documentation or understanding the models. And guys, please feel free, like to interact because it will help this session. Yeah. So with this basic idea, I am going to proceed to the index page where who should be, like what are the prerequisites for this session and what basic knowledge one should have. If you ask me, there is nothing much special required to understand and start with PyTorch and Collab. If you are working with any browser-based system, it is pretty simple, correct? Then the more important questions are why Google Colab and why PyTorch and why PyTorch with Google Colab. So more than how and what, it's more important to understand the whys, because if we understand the whys, we will be in a better position to use them, correct? And we will know when we should use them, correct? The whys answer everything because at the end, the objective should be known first, correct? The stakeholders and the objective should be known first, and then the approach and methodology should be defined. and these all questions are answered through the why approach. So I go with the why approach. That's why I brought it here too. Hello, am I audible?
Yes, sir.
Yeah. Then we will do some basic setups and run a basic program to test whether our environment is functioning. And then we will go to a project using simple feed forward neural networks, correct? And we will also come across at the end certain terms which are very important to understand, and I'll also show you certain libraries and I believe is the best way to approach a particular subject. So with this, I move to the next slide. So the prerequisites, I said, like basic knowledge of Python, including, sorry for the typo over here. Correct. It's including tensors. Okay. So when I say including tensors, what it means is like the way tensors are divided in Python. We all understand matrices, and matrices are more in the way we see matrices are more in a the dimensions for a matrices. There are the data dimensions and then the dimensions of the matrix itself. So there are only rows and columns in the matrices, but there could be n number of rows and m number of columns. But when it comes to tensors, the data fields, basically the dimensions could be multiple sheets. Basically what we are saying is that there is a three-dimensional ecosystem or an n-dimensional ecosystem, correct, is also possible. With that is the beauty of using tensors, and especially where artificial intelligence is there, tensors are the way to use them, correct. A basic understanding of neural networks is required, very basic, like, but people who have fundamentals in statistics or regression, it's easy for them to understand, or linear algebra, it's very easy for them to understand. As far as installation or setting up the system is concerned, it's pretty simple. I will show it to you. And maybe if you, all of you are, like let us make it an interactive session. If you are on a laptop, you can start with, like the setup. It's basically, it's a few steps system, correct? And this will help, removing the fear from the practical aspect of coding, correct. And finally, if you don't know anything, this could be your starting point. And every day, like we at Machadalo believe that one can learn anything uh, at any age. So I will not be surprised that few of you would become expert AI professionals, not only, like training your students, but also developing advanced projects, or using the AI data sets, correct, to train, first train and learn using these simple tools, how they could be utilized. And someday, also using, like data AI sets to generate your own intelligence around thousands of topics which we as a country require. They could be related with the pollution in your city. It could be related with the the sewage distribution system, correct. And interestingly, huge data set is being collected by various agencies right now. The importance is how to use those data sets to finally bring intelligence around them, correct. So these are just the reasons why one should start with something as simple as Google Colab with PyTorch. And the objective of Google here is very clearly is to create, like more and more professionals who bring more and more intelligence to their ecosystems, their local spaces. Even, like in academics or in your labs, cross-functional labs, basically not restricted just to computer science. this can be used. Correct. So right from uh, environmental problems to society or transport problems, everywhere we can use them. Correct. So as I said, the most important questions are why Google Collab, correct? So the most important thing is Google Collab, just like it's a short form of the word of collaborative lab, correct? And we know like everybody has used among you Google Drives, and you have must have used Google Sheets. So what any Google ecosystem allows is it allows collaboration. So Google's primary philosophy is to create ecosystems using agile methodologies. What agile here methodologies means is that people can collaborate at a very quick pace, unlike Microsoft, where people could work in isolation. That was the idea, correct? So Google Colab takes the Python ecosystem where organizations can work in a collaborative way using your drive and the browser. That's it. No installation, nothing required. Correct? So it's a very quick way to start learning various AI models, neural network models, etc. It's very easy and it's a very cost effective way, especially when you are doing research based simple research based projects for school colleges. Then it is very cost effective. Why? Because there is free access to the GPUs and TPUs. So I believe you must be having an idea around what GPUs and TPUs mean. Hello, can you see my screen? Hello.
Yes, sir.
You are able to see my slide right now? Hello?
Yes,
Yeah,
it's first slide.
visible,
Why Google
visible.
Colab?
Yeah. So basically, GPUs, graphical processing units, and TPUs are tensor processing units. These are hardwares, and you must be hearing recently about, like how ChatGPT, we all know, has redefined the way AI has become accessible. But at the same time, the the ChatGPT is the front. At the back end, we know that there is hardware. This hardware is made in such a way that it is very good in processing machine learning related computations. So these are specifically called GPUs and TPUs, correct? And recently you must have heard the news also where China has created a model where the requirement of such hardware is lesser compared to the normal hardware which is utilized. So the tensor processing units, basically everything is computed as a tensor in neural networks, machine learning. And once you send that computation on that hardware, the hardware is designed in such a way, the architecture, AS, the architecture called ASIC architecture, is designed in such a way that machine learning computation is done at a faster pace, lower computational cost is required compared to traditional CPU based systems. Correct. So this is something which is very important to know. So uh, Google Colab gives you free access to these GPUs and TPUs. Correct. Now it also helps, these GPUs and TPUs helps in training TensorFlow and PyTorch. Here we are using PyTorch. We could have also used libraries like TensorFlow. Correct. So now the point is, okay, we have now the hardware which is free. We have a collaborative ecosystem like Google Cloud. Now what do we need more to learn? So we need a system where we can, when we are loading the data sets which are freely available, correct, through Kaggle or through even Amazon and so many other places, once we bring those data sets, we need to then explore those data sets, correct? Then we need to do a basic analysis and a visualization. So to explore and run data sets, what does it mean, explore and run? Basically, it means to create data structures which are more fit to that specific type of data. So here word pandas is important because pandas is a library which comes with Python, and it has multiple data structure libraries where you can create and optimize your data set using those libraries. It is very important to like optimize your data sets. So just like the hardware which is freely accessible, pandas library is also freely accessible, and all the data structure ecosystem which comes with it is also available. Now, once you have the data, you would also like to visualize it, correct? Do some analysis and visualize, because if you don't do a basic analysis, your data set cannot be trained. Okay, to start with, here when we are starting the system, we need not focus on the analysis part. We will only use files which we already are analyzed and put it in a way which in such data sets that it becomes very easy for us to run. But when you are creating your own data, and that is why this session is all about, correct, then you need pandas. You need to create the data in such a way that they meet the requirement to create tensors, correct? If say you if you, there are certain errors in the data is not of a particular format, correct, and data sets are absent or missing or erroneous, then no machine learning algorithm can bring intelligence around it. So this is the after the hardware, the second most important part is one needs to have a good idea around using pandas. And matplotlib only helps you in visualizing whatever you have done, whether the visualization is making any sense. If it is making any sense, it means you have applied the pandas library well. Basically, your data structure is defined well. You have ensured to remove the erroneous data. You have ensured that data cells are not empty, and similar other issues, correct? So these are very important terms, and hence I am saying that why collab, Google Collab, and what are the features which are used in Google Collab. As I said, why is the best way, but we are going to answer all, correct? The third part is collaborative coding and sharing notebooks. So just like as simple as like Google Docs. So in Google Docs, we know like we can share sheets, we can share, and people can jointly work on the same sheet, correct? We can even restrict at certain sheets to certain people, and we can also give an access at a cell level where some other person is working. Now this at a cell level, when it happens, then it gives you the power of collaboration, correct? So in a university or a college environment, hundreds of your students can work simultaneously on a single Google uh, collab ecosystem, correct? And it all happens in real time, so this makes it even better. As I said, Google Colab is primarily aimed at prototyping and experimentation. This is to learn the basics in the threads for your uh, advanced usage of AI. Correct. So this, because it's basic prototyping and experimentation, one should not waste time in setting up the hardware or like defining a new data structure, because those are complex computer science problems, correct? So it should be as easy. The hardware is taken care by GPUs and TPUs which are given free. Bringing libraries like pandas and matplotlib which are part of it helps you in understanding or cleaning and making your data set run analysis based on the requirement it has. So this is very good for people who want to experiment, correct, without setting up complex environments, because that is a big no, like for people who are beginners, correct? Educational and tutorial purposes, it is going to help you a lot by give like in creating assignments or asking your students to create a project, correct? And because it can be shared using in real time, it is very easy for you to understand and in real time assess where and what has been done by various students which you will be taking this class forward to, correct? uh, you must have heard about Jupyter Notebook. So it has a hosted version of Jupyter Notebooks. So basically, it's like when we say notebooks, it by default in Google Colab it means Jupyter Notebooks. So this basically creates, you don't have to even have an IDE. This is like an IDE for Python, where you can run all your execute your code and write your code, correct? Now because every code is being processed using the CPUs and the GPUs of Google. So you are not basically running it in your local machine. So you don't need a high spec machine, correct? So otherwise, complex tasks which involve deep learning, they can be pretty expensive. But and it may take hours or sometimes even days to run and test a model. But because the run systems are run remotely, so the cost is very limited. Finally, this entire system is connected with your Google Drive. So once you have a Google Drive, you are ready to start. So very important is like why PyTorch with Google Colab. So I've already covered few things. No setup required, free GPU, TPU, very much collaborative, correct? Flexibility. What it means is customizing training loops, easily debugging. All this can be done remotely and it is very easy to create, including visualizations of graphs. All the libraries are pre-installed, so you don't need to worry. Even a lot of data sets integrations are there, correct? And it's very easy to load a data set over here. And it's affordable and scalable, correct? So tomorrow, if you feel like, okay, I have learned the basic tools available, then you can go to the pro options, correct? And those pro options will give you better variety. So when one should use, correct? So this should be the question, like for whom it is targeted. So as I said, prototyping and research, educational purposes, and small to medium projects. We cannot run, like Indian Meteorological Department cannot run its project over here, correct? But say for example, if we are sitting in Haridwar, we could say run projects around uh, say various, say the health data of Haridwar, correct, of which has been taken for various vaccination drives, correct, and we would like to understand and gather more intelligence why, say, certain people are skipping certain vaccines and in which geographic area they live or what considerations they have for the vaccination program. This could be a good data set because there are around the district might be having some 3 million to 4 million people. Out of them, say half 5 lakhs would be young kids. So for such projects, it could be a very good way to start with if you get hold of such a data set. Correct. It is right now also there are a lot of these data sets like MNIST and CIFR. These data sets are very basic data sets where there are in MNIST it has numerical numbers written in thousands of ways, correct? So it is helped to detect a number. So it can like convert say a handwritten form uh, into a meaningful digital uh, web form, correct? So somebody doesn't know to write properly, and the accessibility to take a mobile or a laptop, say for example creating, say filling the form for Aadhaar card in a remote area, correct? So there it might be best that fill those forms with say handwritten forms, because taking expensive devices and capturing the details might be an issue, correct? So a data set like MNIST can help it in a big way because it has some preloaded files. Uh, the exact number, if I remember correctly, is somewhere around 60,000 images of these numbers from 0 to 9, correct? And there are also 10,000 testing images where it will show you the accuracy of the handwritten digits. Similarly, there is another important data sets which you can use is cipher 10. Now in this data set there are 80 million tiny images which have been classified into 10 object classes with 66,000 images each, around a 32 by 32 color pixel image. Now this can help in classifying various objects from an image, correct? So this could be used to understand, say various systems. Maybe you can train it further using your own data sets of images, say around, say migratory birds, or say different types of crops, correct? So these two are very simple databases where you can again use them with your students, correct? So finally, as I said, it's perfect where you can, like share the task, like even divide certain kids in your curriculum who are more attuned to algorithms. They could be more working on the data structures and data cleaning part, correct? Or say certain other students who may not understand algorithms that well, they may be interested in collecting and bringing those data sets, correct? Or running the basic code around them, correct? Then others who have a deeper understanding of higher statistics, uh, probability theory, they could then run, say, the optimization parts and the error calculation parts, correct? So this is the way I believe you can, like these are more important aspects than anything which I am going to take further, because how will you use this introductory session in your classroom? That is more important. So now what I will do is I will show you the setup. So what I will do is I have already created certain basic setups, correct? So it's a very simple, go to Google Colab, correct, in your web browser. So what I will do is now I will connect and share this as my screen so that you can see how it is done. So let me reshare it. I'll stop sharing and then reshare my slide. And let me show you a fundamental uh, introduction around Collab. I hope you can see my new screen. Hello. Hello. Can you see it? So what I have done is basically in any ecosystem, I have just gone to, I've typed Google Colab, correct? In my browser. You can also start doing it right now. And if you are already signed into a Google account, you will straight away land into a Google Colab, correct? I'll give you 1 minute where you can, like go to Google Colab, like and if you are already mapped to your Google account, you will be straight away, you can readily open Google Colab. Yeah. In where when you reach over there, you can open a new notebook, correct? So I will just show you, like this is the interface you will see over there, correct? If you want me to show you how so let me in that case share an entire screen, because then you will be able to see how uh, Yes. So am I not allowed to share? Okay. Yeah. Yes. So I've shared my entire screen. This I am doing it just so that you get a idea like how do you reach to Google Colab. It's a very simple system. You type Google Colab, you go to welcome to Google Colab, correct? Of course, you must have already been signed in into a Google account, and here you are, correct? Now, the moment you are here, you can now start with creating a notebook, correct? So I see a notebook is opened because I have already created two projects today for you guys. So I can choose from my notebooks, correct? If you want to create a new notebook, we can very easily create it, correct? So it's a very simple exercise where I just type a new notebook, you can then create it, correct? So I will close this and I will take you to the introductory notebook. Okay, so as I was talking about, once you have created a new notebook, now what should be the next step done? So the next step is you need to import the PyTorch libraries into your collaborative ecosystem. Makes sense. Why will they keep preloaded any such system? Correct, because it is additional cost for Google to put that data and link it to your account. Correct. So how do you do it? It's very simple, correct? One can one can just go, like one second. And yes, so one can go. I'll show you in my ecosystem, correct? Yes. So if I just copy this code, correct, and if I run it, correct, I'll just show I'm running this code. So it's very simple. What they have done is their ID is so simple that you can the running part also you can so see over here, correct? So this gives the current version which I have installed over here, correct? Now this particular version is by a default version, correct? Then what I did was I also wanted to install, correct, all the other important like from the hardware which I want to connect, correct? So I wanted to install Torch Vision, correct? The Torch Vision will help me in connecting with NVIDIA servers, correct, at the back end, correct? So it's now installing all the important packages which would be required to connect to the backend GPUs and TPUs, correct? So you could see it's just one simple command, and don't worry, I've copied all these commands for you, and I will share the presentation, so don't really worry. You What I am trying to show is like what each command is doing, correct? I can also right now copy this and again run it, correct? So I'm just starting here, control V, and I'm running it. So these files have already been there, but I will just show you why it is important. Is first we need to set up, correct? It's a setting up environment. So we have already identified and the version, and now the next steps are like to set it up. Hello, I hope you are able to see my screen where I'm running code. Hello. Correct. So it is already saying it is already satisfied because we have already installed all these packages. So it will also, of course, show that now all these packages are available. Correct. And I have installed whatever version the system gave me. Better it is to set up the most stable version. Correct. Now the most stable version is something you can again go and you can install a stable version. If it is none, then you could do with the current version which you have been provided with, correct? Now here you are seeing, like the CUDA term, correct? What does this CUDA term means? Now this term is important again from the hardware perspective, correct? So basically, what kind of architecture one will be using at the back end. To start with, let us work with simple CPUs, correct? We don't require straight away to work with advanced parallel computing GPUs, correct? Of course, we will be using the TPUs, but we don't need to perform parallel computation, because right now the codes which we are going to write are pretty simple, correct? But as we move and the complexity increases, then you might require parallel computing, correct? So I will go back again to the introduction system. And what I did is, like, then we have installed them. We have also installed other files which are important, correct? So as I said, I have not this particular file is not available by default, but as I said, we are not going with complex ecosystem, so we can do away with it. So these are the important packages which are important to install and complete the PyTorch. We have already covered them, correct? And then let us start with a basic program to see, correct, whether we have correctly all the files are working, and whether the tensors are being assigned randomly. So what I will do is, I will take a two-dimensional tensor because it is easy to visualize, and run the code again, correct? This time, rather than randomizing it to a 4 by 4 column to row matrix, I will do a 3 by 3. Let us see what output it gives. Of course, it will generate three numbers. Very interestingly, you can see all these numbers are between the range of 0 to 1. Correct? By default, the system works for normalized system. A normalized system means, like, where every value is converted into a value between 0 to 1, because that makes computation easy. And why it becomes easy? Because if one set is in, say, trillions, and the other set is in, say, some hundreds, correct? Like, say, for example, if we are working with wealth of millionaires and billionaires, the number of people who have billion amount is very little. So we need to normalize those data, correct? So the normalization is an automatic standard function in tensors. When you write /n means normalized, and it gets printed, correct? If we don't do it, then it will take some other values. Now with this, we have done a very basic setup, and we are now ready to our first project using simple feedback based neural networks, correct? So what I did is, today evening I created an entire project for you guys, correct? So I will start from the top, correct, and I'll explain you, and you can also ask what each system means over here, correct? So there are some keywords over here. So basically, when we start, we need to first import certain data sets. We need to import certain libraries, correct? Because now we want to work with neural networks. Before, what we had done is, we had just completed a basic installation connected with the libraries, which will help us in connecting with the hardware at the back end, correct? But now we are moving to a real neural network project. Now, what is this project about? This project is a simple forward feedback uh, neural network. You must be understanding what is a simple forward feedback system. Otherwise, you can raise hands and I can, like, show it to you in a diagram. Uh, I see certain conversations. For what purpose name is asked for? Now, someone named Mr. SG has asked. Uh, what purpose name is asked for? Can you be more specific? Mr. SG, maybe can you please tell me what exactly you've been asking? Hello? Send the code so that we can practice simultaneously. Wonderful. So, Pratyusha, I will do that. So, what I will do is have you done the installation? Correct. If you have not installed, then it will be bit difficult. Hello? Yes, done. Very nice. So then what I will do is, so first let me define the problem statement. So I will go back and share this tab, and I hope you can see uh, my basic project using simple feed forward neural network. Correct? So basically, as I told you previously, there is a data set called MNIST. This data set has more than 60,000 images, correct, of numbers. Numbers basically handwritten digits between 0 to 9. Now, this data set will help in understanding, say, any handwritten form which consists only of numbers. This data set can convert it into a digital web form with a percentage accuracy. So it's a very simple system. Like the data set is important. The goal is to train this neural network to classify images. They've also given us a 10,000 training data set, correct? So here the objective is like we don't need to upload a file, correct? Of course, that is one can do, but even the training data set is also there. So there is the image data sets, correct, and then the data set one wants to train, correct. Both are there. Okay, then what has to be done? We need to install PyTorch. You guys have done it. Then we will load the MNIST data set. We'll build a simple network using torch.nn, train the model, and evaluate accuracy on the test set. Correct. As few of you have asked me to write the code, I will start writing the basic code over here so that you guys can really get hands-on experience. Okay. So what I have done is one second. I'm going to share my project slide. Okay. And I'm going to copy it to the chat. Okay. So I have done and set the first code, correct? Okay, somebody is asking how to collab start. Yudhvir Singh, what you can do is you can go and type Google Collab on your web browser. If you're already logged in using some Google account of yours, you will get straight away access. Correct? Go to Explorer. I would believe it is better to use a Google web browser. Correct? And once you are on a Google web browser, correct, login, you must have logged in with some Gmail account. If you are logged in, you will automatically be in a position to uh, open collab start, correct. So I have sent the first code. Now there are important things over here, correct, because the code can be easily available today through various means. So finding the code is easy. Now we need to understand what each of these codes means, correct. Yeah. So let us go with what does exactly we need to understand that what does torch.nn really mean and why it is used. So basically PyTorch, what it has done, as I said, it's a very simple way to start your journey on creating neural networks. So these are basically modules and classes, correct? There are three important classes. If you see the code which I have pasted in the chat, they are related with torch.nn, torch.optim, and other data set. correct? I hope you can see that, correct? So, and there is torch.nn functional, correct? So one needs to understand what are these. So these data sets and modules, they carry out different work, correct? So .nn, you could have guessed it, .nn here means the entire module related with the neural network, correct? So basically, when we are using neural networks, we definitely need a system which will help in optimizing the neural network. We need a certain data set and a loader which will upload that data sets in a phase-wise manner, because you can't upload the data in entirety in one phase, because we will train certain data sets and then again we will train certain data sets. So you need data set, you need a loader, you need a neural network, and you need an optimization module, correct? So these four form the basis of PyTorch, why PyTorch is used, correct? You can definitely then customize your neural network, correct? You can combine various combinations of data sets. And here I would recommend that after this class, it will be helpful that you start seeing and reading PyTorch documentation. Interestingly, the documentation is pretty nice, and the notes available on the community ecosystems are also very good, correct? So that will help you get a very good understanding on what each of these systems are used and why they are used. But just to start with, just understand we have loaded a library called .nn. Now the library is loaded. If you need some optimization system, otherwise what will you do with the library, correct? The optimization system will also have some error coding mechanism. So it should have first identifying the error with the predictable and the probable, correct? And then fixing that error, correct? That is the part of optimization. Then finally, you would also require certain vision based, basically you could need a file where you could see a visual representation. So I had previously recommended matplotlib, and also we had installed it, correct? Or we will again install it. So the visualization of your data set, correct, how it looks, that will also help in understanding it. So, and where do you bring in the data set? PyTorch has, like certain open files which are available at Amazon, AWS, and Kaggle, where it imports those files, correct? MNIST data set is freely available, loaded at various places, correct? So I hope the first code is run, correct? If you guys have run, imported the files, it is a very small function, correct? And it is just going to tell you that it has been run, correct? Now the next part comes in where we are going to then, once the data set has been uh, loaded, correct? So the files have been imported, then the next is loading the data set, correct? So I will show you the code where I am going to now copy the code and give this to you, correct? So what I have done is we have defined a simple, because it's a simple neural network, we have defined a class where we are calling these modules, correct? And we are initiating them. As you know, what I hope you know a simple neural network. If you don't know, then it's important that you first understand what is a simple neural network when we are using uh, forward feedback. So this will help you in the second part. I have already sent it to you. This will help you in loading the data set, correct? Now, if you go, I will explain you the code line by line. So if you see, there are three parts to it. So in a simple neural network, it's very easy, very simple. There is one input layer, then there is an output layer, correct? In between, there are hidden layers where there may be multiple hidden layers, correct? So right now we are just moving with one hidden layer with 64 neurons, correct? And the output layer. Now, because we want to classify our files into numbers, digits, basically between 0 to 9. So we just need 10 digits, correct? Now the input, the hidden layers, if you see, there are two layers over here. My bad, I said one layer. The first one has 128 neurons, the second has 64 neurons. Now what does the simple feed forward neural network means? It means that the feedback loop only goes in the forward direction. It doesn't go in the loop doesn't close back into the system, correct? So the backward propagation is limited, correct, to just the last neural system. It doesn't loop back to other systems. So the correction is only done at one layer, not at the training, and the corrections are done only at one layer, not it doesn't propagate complete back, correct? So that is what simple forward feedback system means, correct? Now you know linear basically is means, like you all must have read linear applications in say like starting with, say, a equation of a line, correct? That is also linear, y is equal to mx plus c, correct? But when we are talking about artificial neural networks, there are not just two variables, correct? And we just don't need to find a simple relationship or a simple regression. We could have used a regression model then. Why do you need an artificial neural network? We need it because the variables are multiple, and initially we are saying they are scalar variables, correct? And these variables are so many on which, like the output factor y depends, that we have to use, say, a matrix, correct? And here in the matrix is A, and the T is the tensor. Basically, it is saying the dimension of the matrix. It could be, like 2, 3, 4, correct? Or it could be a simple tensor 0, correct? In that case, it becomes a scalar value, just like the line equation. So a simple regression also can be solved using artificial intelligence, correct? But it is like using something like like a Bofors, where you need a rifle, correct? So you get it. What does a linear system mean over here? Linear over here means basically defining the equation where x is the variable. Here the x is the input image or the value which is flowing into it, and this can be dependent uh, on a parameter or a weight which we will be adjusting over time. So there are two parts. One is the bias, that is b, and the other is the matrix, which we will be we will start with a random basis, and then once certain random numbers will predict accurately, and if it is predicted accurately, then we will mark it as a success. Whenever it doesn't predict accurately, then we will retrain it and try with a different bias and a different matrix, correct? So I hope you get this basic understanding on how we have defined the input layer, the hidden layer, and the output layer, correct? Now you will see we have flattened the images into vectors. What it means is, uh, you can see like a vector uh, has three, like a simple vector, like drawn on an xy plane, has can be very easily defined on the x-axis and y-axis, correct? So basically, images are can be seen into simple xy plane. So each image, rather than seeing it as a point, we are seeing it as we need to know the exact location too. So where it is located in the points, it is better to see it as a vector, because operations on vectors are pretty easy, correct? Then you see certain functions over here, RELU functions. Now these are activation functions, correct? So they are calling the self class, and these functions are now activating, correct? So they have taken certain data set from the MNSIT database. They have created an input system. They have created the architecture for the output system, and they have created the hidden layers, and the activation system is now ready. Now this activation system has also flattened these images, correct? So with these, we have initiated and put it in a feed forward ecosystem, correct? So to understand more, you need to have a basics of how the neural network work. But this is not a course around neural network, so I cannot go more deeper than this, correct? But this would have given you a fair idea on what declarations we need to make to load the data set, correct? And the exact purpose of the function that is called f dot relu, as I said, it's an activation function which which is a rectilinear linear function, correct? So we have, you guys must have, like, had a background in digital signals or something like like analog to digital signals, and you would have found the base functions which is used everywhere is the simplest rectified linear function. That's the most base function which we use, correct? So this activation functions, correct, which we are using, how do we change the bias, how do we, like, so it is better to move one step, correct? And a rectified linear function moves in that way. It changes the values, one for the x value, one for the y value, correct? That is how it works, correct? So with this basic understanding, you would have been able to load the system, correct? Now once you have loaded it, now the part comes in where we need to normalize it and convert it into a tensor, correct? So very simple, like basically we have made our system ready to accept the data which will be coming from MNI asset. We have created the loaders ready, which will help to load the data. And we now, whatever data is coming, we have to convert it into a tensor. These MNI asset images have to be converted because we are using a linear system where we need to define a matrix with a tensor value, correct? So here what we have done is we have normalized the data set, whatever is coming, into a value of -1 to 1. So any pixel can be converted. And what is this two tensor function? Now this two tensor function does a lot of things, correct? And there are many such functions in PyTorch. What they do is, when they are seeing a particular data set, because data sets by person might have a certain bias, correct? So they sort the data, they rearrange the data, they rotate the data, correct? If it is an image, what this does is it takes away the bias. They randomly include some numbers in the data set. So these 4 or 5 things are introduced, correct, without you worrying about how it is being done, correct? So if your mathematical fundamentals are there, and if you understand what this module and this class is doing, it is enough to start, correct? Of course, once you go deeper, you could then play around with the data set by making your own modifications, correct? So here you see, I'm copying this code again for your benefit. So I hope you guys have received it, and few of you have started running this data set, because now you see, like, the two tensor I said is one of those a set of classes where you can actually, yeah, so basically which will help you in transforming the data into the two tensor. So this data is coming from MNIST as images. All these images are 0 to 9 numbers, correct? And they have been there are 60,000 images which they have collected, correct? So the objective is to convert these images and to identify handwritten images correctly as a digital image, correct? With quite good accuracy. So that is what we are creating this algorithm. Now, as I said, the transfer system resizes, it crops, it flips, it adjusts color values. It's easy to work on a gray system, correct? Especially when we just have to recognize the numbers. If it is a colored system, we are adding one more complexity. So the transformation of a to a two tensor takes care of all this. Like it will say make the system gray. It will normalize the value sets uh, over there. It will if there are like values which are much more beyond the range where it is easy for us to handle the data, correct? So basically it adjusts the values, the color values, it adjusts the images, it resizes them, it crops them, it flips them, so that the data set is automatically ready. But again, as I said, this is just a library which I have called. You can go and then create your own resizing system. You can go and create your own cropping mechanism, correct? Or your own flipping mechanism. And that is how, like one should go about, correct? Today, running a program, because the health files and with all the intelligence available, is very easy. But the important point is we need to understand what depth and what can be done. So once these transformations happen, correct, when I was doing it, the data set was found at Amazon and got the data. It also tried certain other links which the Google Colab tried to connect, but it failed. But at the end, we got all the data sets, correct? And with data sets, you see there are three types of data sets. The image data sets, which is one of the biggest files over here, correct? Then the training images. So the training images, you see it's a 9.91 MB file, correct? Which the system loaded into a TPU or a GPU system, correct? Then you would see the training labels. Now see, we need two. There is a 60,000 images which came, and then the 10,000 images which also came with it, correct? So one is the label. So label means like how do we identify an image? So labels will also come with the system, correct? So the label part, and then the how do we save those labels, correct? So that file also is here. So together we have those 10,000 images. We have the images have been downloaded. The entire data set, which is the 60,000 images, you can see the 9.91, correct? The 10,000 data images, you can see the 1.65 MB, correct? And you can also see the path. You need to know the name of the image, so that file also has been downloaded, correct? So till now what we have done is we have done three things. We have imported the files which are being used to create this neural system. Second, what we have done is we have created the basic neural setup. Basically, uh, how many how many neurals will be in the input layer, how many in the output layer, and how many hidden neurons would be there, correct? Third, we have now gone to the AWS part, where we have got the hold of data, and we have also got the both data, the what has to be trained and the training set, both are there. So those data have come, we have uploaded it into the loader, correct? So this part is done. Now the actual part starts. So what is the actual part? That from after loading it, we then run the module. So when we are training the system, correct? So once we are training it, we need to see, we had very clearly identified. Hello. So loading the data set is done. Now the training part comes in, correct? So we have started the training, correct? So I had already discussed about this particular system where I had talked about this particular class. So I'm not going to repeat it, correct? I had initially told about this module which will start training the system, correct? Now, once the training is done, hello, once the training is done, then we move on to so basically we have defined the neural network, we have loaded the data set, we have imported the libraries, correct? Now the concept of loss function and optimizer comes in, correct? What it means is I think I have shared all the three codes with you, correct? So you are not able to download any data. No, it will, you, if you read properly, it is connecting to AWS. So Pratyusha, if you go and read it, you will be able to download it. Hello, correct? You try it again and load the data set, correct? Then we need to run the module, the definition. I think I pasted the module code earlier, correct? uh, Before I had pasted the loader code, correct? But it showed error even at my end. But as I showed you, like from Amazon, it is getting downloaded, correct? You see, from certain libraries, because see, these are sometimes available, not available, so these issues are there. But Google will try multiple sources. Wherever it will get, you will get the images. If there is something wrong at this moment, you can try it, like few seconds later, correct? But these are freely available data sets, don't worry about that. So this particular class now, basically where we are training, I have already defined it, correct? Of course, this will be run once the data set has been defined. I'm again pasting it so that there is no confusion. Yeah. So this part has been done, run it. Once you are done running it, the next important step comes in. Now, once the class is run, now we need to understand the the model which we have run, what are the loss functions and what are the optimizers, correct? So in every neural network, a part comes in where, like we need to understand, correct, how much is the difference between the output which is coming with the reality, correct? So this helps us in first, so for this first we need to define a loss function and an optimizer with it, correct? So we can use multiple systems, but what has been found when we are using, like image based data sets, it is easier to use systems which are log based, correct? Because handling logarithmic values, correct, the ranges are much smaller, correct? Because we know, like once we take a log value of a particular system, of a linear system, then they start coalescing, the data starts, to present itself in a more what should I say, more collated way. Basically, if we take away the logarithmic systems, then it is difficult to see the trend, or say even see the errors. So the cross entropy loss is one such function which is dependent on it's a logarithmic way of seeing losses, correct? And the SGD optimization which I've used over here, correct, again uses the concept of error correction from the perspective of stochastic gradient descent. So basically, in this, why it and how it works is that it uses a single data point at a time. It's an iterative method, correct? It is basically calculating the gradient descent. So how much the gradient descent is in, not in the basically how we can use a gradient descent approximation to minimize the loss, correct? So you see, when you are taking and plotting a logarithmic of errors, correct, and you are also taking the plotting of the values the your log function is generating, correct? So you need to then change the gradient of the function by say a iterative value, and this will bring in, like a correction into the system, correct? So basically what we are saying is, there is a function, the errors when you are drawing it, it will come like a logarithmic function. We know how a logarithmic curve is, correct? And when you want to correct it, use a gradient model where you are changing the gradient, correct, gradient descent, correct, using stochastic approximations, correct, basically random numbers we are using to optimize or the algorithm and minimize the error. So I will share this code also with you. Correct. Now you can see cross entropy loss and the uh, optim SGD model parameters. Correct. Now sigmoid, see, there are so many libraries, so many ways to calculate optimization, so many ways to calculate loss. Correct. And the Python at PyTorch has gives you all the possibilities. Correct. I will show you at the end. Correct. So please don't worry too much about it. So if you don't even know these, don't understand these functions, it is not important. Right now your objective is to run the code, correct, along with me. So I am pasting this too. Yeah. So this particular is the next step, which will help you in optimizing the loss, optimizing the values, which so that your predictive values are more in sync with your probable values. Finally, I move to the point where we would like to visualize, uh, correct. Sorry, before the visualizers, we would like to run this. We have now created the model, we have defined the model, but we still not trained it, we have not run anything. We have just defined, we have loaded the system, we have designed the system. Now we need to run it. So the more the algorithm runs, correct, the more time it runs, the better approximation it is. But again, this is, like, what is a better approximation? Nobody can say, like, because this involves, like, computation time. If you run it for more times, this is called epochs. How many times you are running the entire system over again and again, correct? If you run it say 50 times, of course there will be a slight increment in the output, but then it is taking useful computation time. So you need to identify, like, how much is enough. Maybe 5 is enough, maybe 10 epochs are enough, maybe 4 is enough, maybe 50 are enough. This depends upon when the prediction starts moving to an acceptable number. If the prediction is say 98% accurate, for certain systems you can live with it. Say for example, you want to predict the temperature tomorrow, and by running the epoch 5 times, you are able to come in the range of 90 with a confidence interval of say 95%. It is good. But if it is about a prediction about whether this drug can save a life or not, then you will have to run probably more epochs, correct? So epoch is basically, like, the amount of time we are running these uh, algorithm, what we have defined, running the error systems, running, calculating the losses, correct? How many times we are doing it? So we are running the entire system 5 times, correct? So basically the optimizations will happen 5 times. The corrections in the algorithms will happen 5 times. Basically, the system is auto-correcting itself, correct? For the entire neurons. I'm again pasting this. Hello. So now at this point we have done, this will take slightly more time because when we are running a complete model, correct, this will take say a minute or 2 minutes. You can see when I ran it, it took 1 minute. I hope you are able to see my basic code screen, correct? I can run again for you guys so that you can get a better idea. So you see, like you can see the so many functions are being called, items are being fetched, correct? The backward pass and the optimization, the forward pass, everything is happening. The backward pass, as I said, though it's a feedback system, but it will go. The back propagation will happen at a one level, correct? Where the forward, the end system, when it matches with the correct system, it will tell it that no, it was an error, it was not right, or it was correct. So you see, like 39 seconds have been executed. Don't worry about the functions, too many functions. You just need to understand that we are just calling the images which we have labeled them. We have got the images. We have defined a function. We have also defined the loss function and optimizing using zero grad, basically the SGS function, and the optimizer, the step function, which I told you, like we are using frelu, correct? Yeah, so right now it is taking more time because maybe there are, yes, it took now 1 minute 25 seconds, correct? Finally, we come to a point where we need to, once we have run the epochs, correct? Uh, this like you must have got certain losses, correct? You see the losses are coming down, correct? But the values which are coming down are now not that significant, correct? So here it was like a loss like 7%, and this has gone down to 4.7%, correct, which is acceptable. Maybe you can try with an epoch which is the value is 6, correct? And that may give you a better picturization, like on how this time the model worked. Last time when I ran this model, correct, for those it came down to 8%, correct, when I ran with the losses, correct, 0.08. Here the losses are just 0.04. So this is pretty much accurate, correct? And that is why this is under acceptable limits, correct? Now we would like to see the visualizations for certain systems, like whether the data set, how does it look, how does the prediction works, correct? So I'm finally giving you this particular part of the code. So this particular part, we are going to now evaluate it. So I'm going to share the evaluation code. There are only 5 to 7 minutes remaining, so I will try to wind it up. Okay, and it will also help you in understanding the accuracy. How many correct and how many total errors which happened. So as I said, the accuracy is pretty high. correct? It will change every time because it is randomizing the images, correct? Uh, for the last set which we wrote, the accuracy is around 97.53. Now I'm going to copy the same evaluation code for you. Okay, so this will tell you about how accurate your data set is, and after that the last part, which is the visualization part. The visualization part will run, like how uh, the system will look. I hope you are able to see my screen, correct, where I'm running the code, correct? And so it is getting some images. So see, because it's all randomly picking up images, it is randomly generating it. Now you see, like when I am showing these images, correct? So certain functions I've used over here, correct? So I am taking the background as gray, correct? I have plotted them in a small size where, like the size of the ecosystem. I've given it only, I'm taking only 6 images, correct? And uh, the others are like where they are saying whether, like it's more of what should be printed out, correct? It is showing the prediction. So in a 97% for a 6 image, definitely this will be accurate, correct? You could try it with say hundreds of images and you can see, like you'll find a couple of predictions. So with 6 it's not right because we want to wind up quickly. Maybe you should run it with say 100, correct? And you need to then check what are those 2 3 predictions, why are they coming wrong? And once they are coming wrong, you will understand like where the system might have failed, correct? What might be the reason, correct? So with this visualization part, the final part is left. I will just also copy the visualization part to you. Okay, so one second, I'll answer your question finally. Uh, yes, correct. So this will help you in visualization. There is a question asked by Mr. B. Dhananjay, where he's asking, is there any library in PyTorch that can run 5 to 10 models at once on our data set with basic parameters of the model and give a comparative analysis? Uh, yes, but then you need to, like run them separately, correct? You can create notebooks, separate notebooks, and those notebooks you can choose various models. And because if you're running on the same database, you will see various accuracies coming. And based on which gives you the best fit, you can choose finally, correct? That is an objective. You can't be satisfied with just running one, because this is a simple algorithm which we ran. If you are using, like a deep DNN, deep neural network, correct? We find like the accuracy is very good over there, correct? But you can also choose say something like a random forest, or you can choose say an isolated forest. There's so many. So sometimes, like a random forest might give you a better system than say a simple neural network, correct? I hope this answers your query. So you want me to paste the model evaluation code once more? Okay, somebody has missed it. I will paste it again. I will go to my basic. Correct. So I hope guys this gave you a good idea, and it's very nice to see that few of you have straight away started using Collab. That was my objective, and you have also started using PyTorch. Like say this is an ocean, correct? One class cannot do justification, but I just want you guys to get hooked on. And once you are hooked on, like it's very interesting, especially for professors like you, like faculties like you, because you guys love theory, correct? So I would just recommend that you start reading, like PyTorch, correct? You can start with beginners, correct? But whenever you are reading anything, like you just don't read, also practice. If you just keep reading it, it's pretty boring, and you will not feel satisfaction. So that is the reason Google Colab created this, correct, so that you can run simultaneously run this on real time, correct. Sometimes you may not understand the mathematical complexity. That is what this system has done. It has hidden the entire mathematical complexity in the background. You just choose models and run. It's not a very good thing. This is, like a big problem which I am seeing in the industry. A lot of people have done this course, that course, and they show themselves as like data analysts, but they hardly understand any maths behind it. They don't even understand basic statistics. But with you guys, this is not a problem. A lot of you will not only understand basic statistics, but advanced probability theory, which is recommended, various types of mathematical functions, various types of, like optimizations, time series, regressions, correct. So this is something which will not come as a big like a problem for you. So I believe the real data analysts could be professors, and that is why I agreed to, like have an introductory class around this with you guys. I hope you guys, like enjoyed it. Will say, like like these technologies have been developed collaboratively. The best documentation is the PyTorch website, correct. But as I said, the PyTorch website talks about all the libraries. It also talks in the basic parts when it comes to certain functions, but what it doesn't talk about is the mathematics involved over there. So for that, your fundamentals around Python should be good. Your fundamentals around NumPy, which is a library of Python, and using all possible, like the statistics library of Python, the maths library of Python. That is where really will help you become a true data, analyst or a data scientist, correct. And your students can also become. Right now, thousands and thousands of people are claiming, like after doing these simple courses where they just know how to run the system, they don't understand nothing, they just run four models and say this is the best, sir. But why we have chosen a particular model, why it will benefit, though it is not the subject over here, but I, like believe if the fundamentals are not there, these models are of no use. With this, I complete my system, correct. I will definitely share this to Mayank, and you guys can, like go through the content, correct. It also, there are certain terms which are very important, which I had defined. You guys also should read about them, make your own notes. Thank you, guys.
Thank you, Anupam ji. It was a great learning experience for all of us, and I would request the participant to give the formal thank.
Thank you, sir. It is with immense gratitude that today I want to thank our distinguished key speaker, Mr. Anupam, for delivering such an insightful and inspiring address. The wisdom and experience you shared today will undoubtedly resonate with us long after this event too. We deeply appreciate the time and effort you took to be here with us, sharing your expertise in introduction to Google Colab and PyTorch. Your message has left a profound impact, sparking new ideas and enthusiasm among all. Thank you all once again to all our distinguished speakers, guests, organizers, and all the participants. Thank you all.
Thank you, guys. I am signing off.